So we're making a scary owl today, and we've got, this is just going to be a scary owl to scare away pigeons on the balcony. And the parts we're using are a Pizeo Buzzer, which is going to make just a sound, that a frequency that's supposed to scare off pigeons, and an ESP32. You could easily use an Arduino, but I had an ESP32 lying around, and also I think it's a bit smaller, more compact, so it's going to be easier to connect into the project. We've got a potentiometer, and the potentiometer is going to be used to control the volume of the buzzer, hopefully, because it can get a bit annoying for the neighbours and if you're sitting on the balcony. A motion detector, so this will detect whether there's birds flying around on the balcony. This is an HIR motion detector, and I might actually use a couple of these. This is a 501, and then I've got these LEDs which I'm going to use for the lights. These are 82611, I think, LEDs, which I just got off AliExpress. And then I've got, this is a servo which I'm going to use to turn the owl's head. So let's get started. All right, the circuit's ready for testing. Here's the motion sensor, here are the lights, and this is the servo. So what I'm going to do, and here is the buzzer. So what I'm going to do, I'm going to set it up, I'm going to plug this in, and then I'm going to walk in that door over there, and I'm going to see if it goes off. Okay? All right, cut. So this is the code for the scary owl. We use two libraries. The first one we use is the Adafruit NeoPixel library, which is for the LEDs, and the other one is the Servo library, which is for the servo. Now, each time the owl is triggered, it stays on for 4 seconds. You can experiment with different values, but I found 4 seconds was pretty good. These are the colors in HSV space for the LEDs, which I've used those in lots of projects, so I just keep them there. This is the definition of the NeoPixel strip, and these are just standard values. The brightness I've just set to 200, 255 is the maximum, but I thought 200 is okay if I'm going to run it off batteries. The servo object we initialize, the position is 90, which is the initial position of the servo, and the servo is connected to pin 5. This is set up here for the for PWM for the buzzer, and you noticed I've got it here on channel 0, but I actually need to change that because channel 0 is being used by the servo. So if I put it here on channel 0, it's going to make the servo go a bit crazy, which is why it was spinning around before. So if we set it here to 3, it should be fixed and just move back and forth like it's supposed to. So that's usually the issue when you've got a crazy servo. It's usually a timing issue or it's on a wrong channel or something. So the motion sensor is connected to pin 27. These are my timing variables. This is the interrupt function that gets triggered every time there's it senses motion, which it just basically sets a Boolean value to true and then starts the timer so it can switch the Boolean value off after 4 seconds. And then we just have a servo setup function, a pixel setup function, and then the flash colors just changes the colors of the eyes, flashes red and orange. So the left eye is orange, right eye is red, then right eye goes orange, left eye goes red. And then this plays the sound, which is supposed to scare off pigeons. It's a 1.3 kilohertz and 2.7 kilohertz at 40 millisecond intervals. So this moves the servo by 5 degrees, either left or right, every time it's called, between 125 and 45. And you can play around with these values. These were basically chosen by trial and error. And then this is the setup function. We just start the serial monitor for debugging, then set up the PWM channel for the PWM signal for the buzzer. The motion sensor, we just attach it to a digital pin. We set up the pixels and the servo and attach the interrupt to the motion sensor, and then we just delay for 2 seconds just so everything can settle down a bit, especially when the motion sensor needs a bit of time to just warm up. So this is the loop for the scary owl code, and there's 2 conditions in this if statement: start timer, which means we've had an interrupt, and it's been more than 5 seconds since the last interrupt. This is because we don't want the owl to just keep going off, so we wait 5 seconds between interrupts, and you can change that if we want. So if that's true, then we play the sound on the buzzer and we flash the colors every second. So we flash the eyes between red and orange every second and move the servo. And then after 4 seconds has passed, 4,000 milliseconds, we turn everything off and wait for the next interrupt. And I'll include this code and a list of parts in the description below. So I've built this frame for the scary owl out of vintage Meccano, and I'm going to mount it on a piece of acrylic that I got from the hardware store and cut up. And so this is the frame, and then on top of here I'm going to put a servo with a picture of an owl, like the scary owl, and lights in the eyes. The LEDs are going to go in the eyes. And this is a Lego box for the electronics, which is going to go under here. And then the battery can go down here somewhere, and the motion sensor will go here. The servo up here with the owl's picture on it. So I'll show you again once I've got all that assembled. So I've laminated this picture of an owl. Before I put it in the laminator, I cut the eyes out, so I can just cut the plastic out of the eye, because I don't want to cut it where the picture is, otherwise the paper will get wrecked. So I've cut this eye out on this side now, and I'm just going to stick lights in the eyes, so when it senses motion it's going to light up. So I'll show you how that goes. Okay, now I've stuck ping pong balls in the owl's eyes for diffusers. These are the ping pong balls, and I've just stuck LEDs in the back of the ping pong ball. So there's one there, and then I'm just going to stick this one in like that. There, there's a little hole in there, and light those up when the motion sensor goes off. Hello everyone, I finished the scarecrow, the owl, to scare away the pigeons, and this is it. So it's got the motion sensor here at the bottom, which is going to detect if there's a pigeon nearby, hopefully. And then I put all the electronics in this box here, which is the box I made out of Lego. There's a buzzer, which is specially designed to make a noise that's supposedly at a frequency supposedly to scare away pigeons. It's supposed to be in line with a pigeon's distress call. And then this is the face of the pigeon with the 2 eyes, which are ping pong balls with LEDs inside them. And underneath there I've got a servo, and I've got everything attached basically with hot glue. And then I've got all the wires coming up out here, and then I've got a little button here which turns the buzzer on and off. And I've just used one of these switches just to turn it on and off. So I'm going to turn it on now. Alright, so it's switched on now, and when we touch it there, it goes off. Okay, so ready, set, go. I'm going to wave the motion again, just in front of the motion sensor, and set it off. Alright, and I've got this button here. If I switch this, it'll get rid of that annoying beeping, which is supposed to scare off pigeons. So there we go.